Okay, so I'm just picking up from the last video. I seem to have lost the sound for some reason. So anyway, I just wanted to do a couple examples of each of these. Uh, so back to our candy cup with one of each color in it. Um, let's say I ask, what is the probability of drawing a red candy 8 times? And in this case, I mean pulling one out with your hand, terrible hand here, pulling out a candy, writing down its color, and then putting it back in again, and doing this, shaking up the cup and doing it again. So really what you're doing is drawing a red candy, a red candy, a red candy, a red candy, and so on 8 times. So this is 8 events, right? So what we're going to do here is we're going to just apply this concept instead of doing the 1/6 times 1/6. We're going to ask ourselves total possible outcomes. We're going to focus on this bottom number first. And the bottom number is, well, n is equal to 6. N is how many things you are choosing from, right? And we have 1, 2, 3, 4, 5, 6 choices in there. Right? And we are going to choose them. We're going to take it out 8 times. So this becomes 6 to the power of 8, right? Or we could, that would be the same thing if we did 1/6 times 1/6 times 1/6, all the way 8 times, okay? That is when we would use this one. All right, when you're putting things back, when the n value does not change with each event, it stays the 6 each time you're throwing it back in. It's like pin code. And on the top, how many ways can we get red candies? What's my number of successes? Well, just the one way. Okay. All right, let's try another one. Okay, if I ask the question, how many ways can I arrange my 6 candies? How many ways can I arrange the 6 candies? That is simply 6 factorial. N is 6. N is staying 6. I still have 6 candies to choose from up here. So how many ways can I arrange 6 candies? 6 factorial. You can do that on your calculator, whatever that number is. For those of you who have the TI-34, what you would do is you would hit the number 6, then you'd hit the PRB button, kind of in the middle there, and you'll notice that 3 numbers come up. If you go down to number 3, you'll see the exclamation mark, and you'll hit it, and it will come out as 720. There's 720 ways that I can arrange these 6 candies. So if I ask the probability, what's the probability, for example, that I would get them in this very specific order? I'm gonna stick my hand in and pull out all the candies and lay them in order with my eyes closed. What's the probability when I open them that I've drawn the red one first, the orange one second, the yellow one third, the green one, the brown one, the blue one, and then the brown one in that order, that exact order? There's only one way I can do that. There's only one way out of the 720 different ways that you can, that they could be arranged. All right, so it's all the different ways. All the ways you can arrange them is 6 factorial, one of them being correct. Okay, let's try something else. Okay, let's take a look at a problem that might involve a permutation. Let's say we have 20, well, we have 22 students in our class. And let's say I need to choose, we need to pick a president of the class, a vice president, and a secretary. Okay, we're running elections or something like that for our class, okay? My question is, how many different ways can we choose these 3 people, okay? Now, think about it. In this case, order does matter. Let's say I list everybody's name in the class. I'm just going to use letters A, B, C, D, E, F, and so on. These are all the students in our class. So let's say I happen to choose the students A, D, and E. Those are the 3 people. Well, even within those 3, A could be the president, D could be the vice president, and E could be the secretary. Or D could be the president, A could be the vice president, and E could be the secretary, or something like that. So order does matter for this kind of problem. So the question is, how many ways can I do this? Well, we just use our calculator. We have 22 students to choose from. N is is everybody we have to arrange. And we don't want to arrange the entire 22. It's not 22 factorial. We just want to arrange 3 of them. So in other words, we're going to choose 3 people and then we're going to arrange them. And the question is, how many ways can that be done? Well, if you use your calculator, you're going to hit the number 22, then you're going to hit that probability button again. And it's number 1, and then you'll hit the number 3 and hit enter, and you'll get 9,240. 9,240 ways that you can come up with a president, a vice president, and secretary just in our little class of 22 students. So what's the probability that you get chosen as the president? Let's say you're student A and your partner gets chosen as vice president. Let's say he's student D, and let's say you're the person behind you, student E, gets chosen as secretary. What is the probability of that one situation happening? Just the one out of the 9,240 different ways. Okay. So that's when we would use a permutation, when the order of the things that you're choosing matters. You need to count. You need to take that into account. All right. So let's take a look at that last one. Going back to right back where we started this whole long video or the previous video. If I were to ask you this question again, what's the probability of getting putting your hand in and pulling out 3 candies all at the same time? It's still 3 events, but you're pulling all 3 out. What's the probability you get the red one, the orange one, and the yellow one? I'm not saying that you have to get the red one first and then the orange one and the yellow one. I'm just saying in your hand are those 3 colored candies. All right. Well, the way we're going to do that is what's the total possible outcomes? That is our NCR, where again, N is 6. We have 6 candies to choose from, and we're going to be choosing 3 out of the 6. We're going to be taking 3 candies out of with our hand. Okay. How many different ways can that happen? The number of successes, well, there's only one success. It's the red, the orange, and the yellow. And so again, how do you do 6? Choose 3. You would type in 6, hit your probability button. This time it's number 2, enter 3, and enter, and it goes right back to that 20. 6 choose 3 is 20. So we're right back where we started. All right. So in the end, we have learned four basic counting principles. When your numbers sort of stay the same and repeat, you're going to have n to the power of r, however many digits your how many numbers in your PIN code. Think of that as r. If you want a 4-digit code, then r is 4. If you want an 8-digit code, then r is 8, and so on. And that's when you can repeat the numbers. That number stays constant. If you're decreasing, you're not replacing things, or you can only use things once, then you end up with that factorial. Instead of over here where you have 10 times 10 times 10, you have 10 times 9 times 8. How many ways can you arrange something? Let's say I have 20 songs in my playlist. All right, and I'm going to put them in an arrangement, or I'm going to hit shuffle play. How many different ways could those songs play? How many different orders? So you could hit 20 factorial, and that's how many different ways you could arrange your 20 songs in your playlist. And it's going to be a big number. Check it out. Then we have the permutations, NPR, where you're arranging only R out of a set of N. So if you go back to those 20 songs, how many ways can I arrange 10 of the songs? 20 factorial would be how I arrange all of them. But let's say I only want to choose 10 out of the 20, and then I want to arrange those. I can do that 20p10. So that's the arrangements. Arrange R things out of a set of N. Whereas this is arrange N things, things for lack of a better word. And then finally, we have the combinations. where order does not matter. How many different ways can I choose our things out of a set of n? So if you go back to that 20 songs again, how many different ways can I just choose 10 of the songs to play at a party? Order doesn't matter. What are all the different? So this is going to be a much lower number than your permutation. So how many ways can I choose our things out of a set of n? Okay. This is going to take some practice, guys, but you can do it. All right, good luck.